Hi guys, welcome to the lesson of ordinary differential equations. So in the previous class we discussed and solved some problems on uh, separable equations, variable separable equations. So in this class we are going to talk about the homogeneous first order differential equations, and we will see that how to solve these problems and what is the approach behind solving the problem. So an homogeneous equation is of the type dy over dx is equals to function of xy divided by some function of xy, right? So if we are given with this type of equation, and what we have to check here is that we have to check that the power of all the powers of the equation are same as in the numerator and in the denominator. Let's take an example. If we say that it's x plus y over 2x minus y, so we can see that the power of x is 1, the power of y is 1, and here also the power of x is 1 and y is 1, right? So in this way, if the problem is given of this kind, then we can call it homogeneous equation, and we can solve it using the approach of homogeneous equation. And also if we are given a function like this, that is dy over dx is equals to xy plus y squared divided by x squared minus y squared, then also we can see here that the power of this function is 2, and the power of this function, this y, is also 2, here 2 and 2. So all powers are equal, therefore we can call it homogeneous equation and we can solve it easily, right? So let's take an example and start solving the problem, and we will see how to approach the problem. Therefore, first of all, we'll write the steps to solve this problem. So the first step to solve this problem is to assume that y is equals to v times x, or u times x. You can use any variable here. So we assume that y is equals to u times x. Therefore, if we differentiate this with respect to x, what we will get is dy over dx is equals to u plus uh, x times du over dx, right? This, and then we can substitute in the equation. So uh, now then step number 2 is we can separate the variables easily. We can now make it separable equation. So separate the variables, and simply then we can integrate the function, right? So the third step is integrate. All right, so it's a pretty simple procedure. Let's take an example. So question 1 is given as 2xy it's 2xy plus x squared dy plus sorry, it's minus 3y squared plus 2xy dx is equals to 0, right? So first of all, we will write this equation in the form of dy by dx. Therefore, we should move one of the equation to the right hand side, so it will be 3y squared plus 2xy times dx. Then we want to write in terms of dy over dx, so it will be equals to 2x sorry, 3y squared, 3y squared plus 2xy divided by 2xy plus x squared. Now we can see here that the powers are same. Here it's 2, here is also 1 1, which means 2. Here is also 1 plus 1, which means 2, and here it's also 2. So it's a homogeneous equation. Now we can assume that let y is equals to ux. Then we have dy over dx is equals to u plus x times du over dx. Right. Now we can substitute this in the equation. So in place of dy over dx, we can write u plus x du over dx, and it's equals to 3u squared plus 2x times ux divided by 2x times ux plus x squared. Now we can sorry, here we did something wrong. It's not 3u squared only, it will be 3u squared x squared. All right, because it's y squared. So now we can take x squared common here. So you're left with 3u squared plus 2u over x squared common again in the denominator. We're left with 2u plus 1. So now we can cancel out x squared and x squared. So you're left with u plus x du over dx is equals to 3u squared plus 2u divided by 2u plus 1. Now we can just simplify the equation by moving this u to the right hand side and taking LCM. So it will be over 2u plus 1 minus u, right? Now we can simply take LCM, and so it's x du over dx is equals to 3u squared plus 2u minus 2u squared minus u divided by 2u plus 1. And then by simplification, we have u squared plus u over 2u plus 1. Now these variables are separable here, we can see. So we can simply write 2u plus 1 over u squared plus u times du is equals to dx over x. Now we can simply integrate. All right, so equation dy by dx is equals to y over x plus x sine y over x, right? Now again, we cannot separate the variables in this form. Therefore, we just need to transform this equation. And again, we can see here that it's a homogeneous equation because it's y over x. The power of y is 1, power of x is 1. Again here, it's y over x and power is 1, right? So y is equals to ux will work for us. Then dy by dx will be simply equals to u plus x times du over dx. And then we just substitute here is equals to ux over x plus x sine ux over x. So this cancel out. So it's u plus x times du or dx is equals to u plus x times sine u. Now this u and u cancel out, and we will left with x du over dx is equals to x sine u. Again, this x and this x will cancel out. So we will left with only du or dx is equals to sine u. Now this equation is separable. So it's du over sine u is equals to dx. So we can integrate. So this sine u is simply cosec u, and du is equals to dx. So the integral of cosec u is ln tangent u over 2 is equals to x plus c. And then we can simply substitute the value of u, that is y over x, so it will be y over 2x is equals to x plus c. And this is the solution for this equation, right? X plus c. So this is the final answer. Now let's take one more example. Say we have a question that is x, or let's take this example, dy over dx is equals to y plus x squared plus y squared in the square root over x. Now we can see here that the power of y is 1 and the power of x is 1, and the power of x and y is 2 in the square root. So it's fine. Again, we can work here because in the square root. So if we assume that y is equals to ux, which implies that dy by dx is equals to u plus x times du over dx, and then we will substitute here x times du over dx is equals to ux plus square root of x squared plus u squared x squared over x. So it will be u plus x du over dx is equals to ux plus, then we can take x squared common, and when we will move it outside the square root, so we will get x, so it will be like this. And now we can simplify this equation. So x du over dx is equals to this x, and this x is common, so it will be cancel out with the x in the denominator, and we will left with this minus u. So u and u cancel out. Therefore, we are left with x du over dx is equals to square root of 1 plus u squared. Then we have du over 1 plus u squared. Square root is equals to dx over x. Now we can simply integrate the function. There's integral here and integral here, right? So we know that the integral dx over a squared plus x squared is equals to ln x plus square root of a squared plus x squared plus c, right? So we can write here, we can compare this one with this. So this integral will result in ln u plus 1 plus u squared is equals to ln x plus ln c. Now again, using the properties of logarithm, we can just manipulate this function. So it will be ln cx. Now we can raise both sides to the exponential to cancel out this ln. So we're left with u plus 1 plus u squared in the square root and c times x. Now this u is equals to y over x plus 1 plus y squared over x squared is equals to cx. You can simply take out 1 over x outside. We're left with x squared plus y squared is equals to cx, and move this x to the right side. So we're left with this function is equals to cx squared, and this is the solution for the given differential equation. So in this way we can solve these problems, and I can give you some practice problems so you can practice, and you can ask in the comments section if you are finding any difficulty in solving these problems. Right, it's dx plus y squared minus x squared ln x over y times dy is equals to 0. Right, so you can solve this problem. And one more problem is x cosine y over x plus y sine y over x times y minus y sine y over x minus x cosine y over x times dy by dx is equals to 0. Right, so try these problems, and I'm also giving you the answers for these problems. So the answer to this problem is xy cosine y over x is equals to c. Right, this is the solution for the given problem. So that's all for the time being, and for the next lecture we'll come up with some equations that are reducible to homogeneous equations, that are actually not homogeneous but that are reducible to homogeneous, and then we can reduce it further to the separable, and then we will solve the equation. So we'll see how to solve, what is the procedure to solve that particular type of equations. So that's all for the time being. Thank you for watching the lesson.